After finishing his lab report, Carlo pulls his 75-kilogram body out of the study room chair and climbs up the 5-meter-high flight of stairs to his bedroom. How much work does he do in going to his bedroom? Okay, before solving any problem, the first step that we are going to do is to identify the given. We have in the problem the mass of Carlo, which is 75 kilogram, and the displacement or the height of stairs, which is 5 meters. If you've watched the first video or the part 1 of this video, you will know that the formula or the equation for work is force times displacement, where F or where the unit of measurement of F is in Newton, and for the displacement we have meter. Okay, going back to the given, you notice that only the displacement is given and there is no force here. So what will you do first? By the way, I will be introducing 2 steps on how to solve for the value of work in this problem. Okay, let's go first to the step 1, or let's go first to the first step. So here's how. We are looking for the value of work here, so work is force times displacement. Okay, so you may choose to solve first the value of work. The value of force. Force can be calculated by using the equation or using the formula F is equal to mass times acceleration. Okay, but you may also use this one. Weight is equal to mass times acceleration due to gravity. Remember, these two are the same, okay? Or the only difference is that this one is more specific to weight, and G here is, of course, acceleration due to gravity. While this one here is more specific to force, and the A here means acceleration, but not necessarily of that of the gravity. Okay, but in this case, we can use this one, okay? F is equal to mass times acceleration. So, mass of Carlo is 75 kilogram, and we will be multiplying it with the acceleration due to gravity, which is 9.8 meters per second squared. Okay? So, 75 times 9.8, what is the answer? So, the correct answer is 735 newtons. Okay, again, take note, force, the unit of measurement is newtons. Now, we already have the value of force, so we can now solve for the value of work. So, since work is calculated using the formula force times displacement, we will just substitute the value of force with 735 newtons. 735 newtons times the displacement, which is 5 meters. So we will now multiply 735 and 5. So the correct answer is 3,675 joule. Take note, okay, that the unit of measurement for weight or for work is joules, named after James Prescott Joule. Okay, you may also choose to solve this problem using this formula. Work is equal to mass times acceleration times the displacement. Okay? So mass is 75 kilogram. Multiply it with the acceleration due to gravity, which is per second square, or you may also replace it with G if the acceleration is, of course, due to gravity, and D for the displacement, which is 5 meters. If you multiply all these three, you would still get the same answer, which is 3,675 newtons. So it depends on you on which formula you're going to use. You may use this one, or you can also use this one. A cart is pushed by Sansa with a 200 Newton force on a plane inclined at an angle of 22 degrees to a distance of 7 meters. Calculate the work done here. Alright, so this time we are going to calculate for a work done at an angle. the equation for the work done at an angle is W is equal to force times cosine theta times the displacement. So this symbol here is a Greek letter, it's a Greek letter called theta, which symbolizes angle. Okay, so again, first step in solving a problem is to identify the given. So the force in the problem is 200 newtons, and then the displacement is 7 meters. Okay, the angle in the problem is 22 degrees. Okay, so everything is provided. Now let's go to our solving. Okay, so force is 200 newtons. Now we are going to look for the cosine theta. So what is the cosine of 22? And then after that we will multiply it with the displacement, which is 7 meters. Okay, cosine of 22, that's it, cosine of 22, the answer will be 0.927. Okay, so 200 newtons multiplied by 0.927, then finally multiply it with 7 meters. So the correct answer will be 1297.8 joules. So this is now the work done at an angle in the given problem, which is found in the PowerPoint presentation about work, power, and energy in your Schoology account. Part 2.2 to follow. Please hit like and subscribe for more science videos and tutorials. Thank you!